Something extraordinary is happening in China that will forever change how we move around the planet. Can you imagine traveling faster than a commercial airplane but on land? Well, China has just achieved it. While some countries are still using trains from the last century, China has created machines that seem straight out of the future. From trains that float completely in the air without touching the tracks, to mechanical beasts capable of breaking the sound barrier. Today, I'm going to show you the 8 fastest trains in the world, including the impressive Chinese supersonic train that is completely redefining the limits of ground speed. Stay until the end because what you'll see at number 1 will undoubtedly leave you speechless. If you like these analyses, comment with a number 1. If you don't like them, comment with a number 2. Don't forget to like and subscribe to the channel. You'll be among the first to see these exciting videos when they're released. Welcome to Expand Knowledge. As we enter the year 2026, the global race for ground supremacy has reached an unprecedented boiling point, forcing us to reevaluate everything we know about transit infrastructure. We begin our countdown with number 8, a project that represents a monumental leap in Chinese innovation, the Chinese T-Flight maglev. This machine has completely changed the rules of ground transportation, reaching an astonishing speed of 621 miles per hour during recent trial phases. To put that into perspective, a standard commercial jetliner cruises at around 550 miles per hour, meaning this vehicle comfortably outpaces a Boeing 737 on the ground. The engineering secret relies on a superconducting magnetic levitation system, which lifts the train completely off the tracks, eliminating mechanical friction entirely. However, the true breakthrough lies in the utilization of low-pressure vacuum tubes. By launching the train through an environment with almost no air resistance, engineers have replicated the atmospheric conditions that allow spaceships to travel so fast. This allows passengers to journey between Beijing and Shanghai in less than 2 hours, a trip that normally requires 4.5 hours on the fastest conventional rail lines. From an American analytical standpoint, this level of development forces us to examine the long-term economic viability of such massive capital investments. While building thousands of miles of sealed vacuum tubes requires astronomical upfront funding, the operational efficiency gains and reduced reliance on domestic aviation could fundamentally reshape regional economies. We must consider whether the high cost of maintaining these magnetic guideways justifies the immense energy savings over traditional air travel, especially when comparing giant landmasses like the United States and China. This jaw-dropping speed is no longer a blueprint. It is a tangible reality that challenges traditional engineering frameworks. It marks a profound shift in how modern superpowers approach civil engineering and public utility, creating an entirely new paradigm for domestic connectivity. As we observe these rapid transformations, it becomes clear that the boundary between ground transit and aerospace engineering is dissolving right before our eyes, signaling a future where geography is no longer a barrier to human potential. We move forward with number 7 on our list, the CRH-380A, a massive triumph that proved domestic engineering could excel on the global stage. This mechanical monster reached an official test speed of 261 miles per hour, leaving international observers completely astonished. Its brilliant aerodynamic silhouette draws direct inspiration from modern fighter jets, featuring an elongated nose that slices through thick air like a sharp sword. However, as an analyst, I find that the most compelling aspect of this machine is not its peak velocity, but its incredible structural endurance. The train can comfortably sustain speeds of over 217 miles per hour, for hundreds of miles without experiencing mechanical wear. The secret lies in its advanced cooling system, which utilizes liquid air to maintain optimal engine temperatures during hours of continuous operation. Furthermore, it receives constant electricity while in motion, eliminating any need for technical stops. It covers distances that typically require domestic flights, running without rest across territories that other nations consider impossible for ground networks. Right after that, at number 6, we encounter the remarkable CR380D, which marked a definitive turning point in manufacturing history. While previous generations relied heavily on imported European and Japanese components, this machine is 100% built from scratch, using domestic expertise. You see, the most striking characteristic of this high-speed vehicle is something you would never expect. It is practically silent. While other locomotives roar like jet engines, this one passes quietly like a ghost. You can stand right beside the tracks and barely hear a faint whisper as it flies past at over 217 miles per hour. Its spectacular dragon head design is not just for visual aesthetics, it is pure aerodynamic engineering applied to absolute perfection. This long, curved nose reduces air resistance so efficiently that it cancels out almost all acoustic vibration. Engineers achieved a beautiful balance, combining intense speed with complete silence, showing that foreign guidance was no longer necessary. As we look at these achievements, we realize how fast ground transportation is shifting, and we must wonder how these systems will adapt over time. This brings us closer to understanding the true scale of modern transit, which continues to accelerate every single day. We are witnessing an incredible golden age of engineering that is completely reshaping our global landscape. Crossing the ocean to examine another major powerhouse, we find number 5 on our list, the legendary Shinkansen E5 from Japan. This bullet train is a masterclass in operational perfection, reaching a reliable commercial speed of 199 miles per hour. Yet, its true strength lies in its unmatched punctuality, boasting an average annual delay of a mere 18 seconds. Every single component is meticulously calculated to function like a Swiss watch on rails, utilizing artificial intelligence to detect potential structural anomalies before they can occur. Interestingly, the E5 features a highly sophisticated regenerative braking system that actually generates more electricity than it consumes when traveling downhill. This specific technological integration highlights an important ecological impact, as the system dramatically lowers carbon emissions and reduces the overall energy drain on the national grid, offering a sustainable alternative to fossil fuel consumption. Right next to this icon, at number 4, sits the revolutionary L0 series maglev, an absolute marvel that elevates trackless transit to a completely new dimension. Capable of hitting a breathtaking 375 miles per hour in testing, this super vehicle is scheduled to enter official service in 2027. It utilizes an advanced superconducting magnetic levitation system that suspends the entire train 4 inches above the guideway, eliminating friction entirely. This profound technology will soon connect Tokyo to Osaka in just 67 minutes, a journey that currently takes over 2 hours on traditional bullet lines. By floating in midair, the L0 removes mechanical wear and tear, combining strict safety protocols with record-breaking velocity to redefine our expectations of future travel. When we analyze these breakthroughs, we see how environmental efficiency and high-speed magnetism are converging to challenge older transportation frameworks. It raises fascinating questions about how different nations prioritize resource allocation, sustainability, and civil mobility in the modern era. What do you think about this incredible level of precision and energy efficiency? Do you believe sustainable high-speed rail could eventually replace short-haul flights in your region? Please share your thoughts and write your opinions down in the comments section below so we can discuss them together. Returning to the European continent, we discover number 3 on our list, the sophisticated German ICE-3. This high-speed beast perfectly maintains the formidable reputation of the nation that pioneered magnetic levitation engineering, reaching a maximum test velocity of 228 miles per hour. While it operates commercially at a controlled 186 miles per hour for safety optimization, its true engineering secret lies in a revolutionary distributed traction technology. Unlike traditional models, power is distributed evenly throughout the entire frame, allowing it to accelerate and brake with unmatched efficiency. Furthermore, its active tilting mechanism enables the vehicle to navigate sharp curves at velocities that would instantly derail conventional trains, maintaining flawless equilibrium through continuous track monitoring sensors. Every surface is mathematically shaped to minimize aerodynamic drag, utilizing specialized metal alloys designed to endure decades of extreme operational wear. This brings us directly to number 2, the remarkable Italian Italo AGV, a privately owned marvel that operates smoothly at 186 miles per hour. This sleek vehicle connects major historic cities with an operational efficiency that continues to impress transit authorities across the Atlantic. What makes the Italo exceptionally unique is its complete elimination of traditional heavy locomotives. By scattering compact motors beneath the passenger cabins, it maximizes interior space while significantly lowering the overall center of gravity. Constructed from ultra-lightweight composite materials, it dramatically reduces total mass, translating directly into lower electricity consumption and rapid acceleration phases. An advanced pneumatic suspension system absorbs almost all ground vibrations, creating an incredibly smooth passenger experience, even when pushing the laws of physics at maximum velocity. The Italo AGV beautifully demonstrates how combining intelligent aerodynamic architecture with efficient power distribution can yield an exceptionally reliable transit network. European engineers have focused heavily on perfecting these standard steel wheel systems, proving that traditional tracks can still achieve incredible feats when paired with creative design philosophies. This brilliant approach to regional connectivity offers a distinct contrast to the massive infrastructure overhauls seen elsewhere, balancing classic mechanical wisdom with modern material science. Finally, we arrive at the absolute pinnacle of rail engineering with number 1, the experimental Shinkansen Alpha X. This 10-car masterpiece stretches an impressive 1,050 feet in length, completely shattering previous speed records by reaching 249 miles per hour during its rigorous testing cycles. The Alpha X utilizes extraordinary diagnostic systems, analyzing over 10,000 distinct data points in real time to monitor environmental changes and microscopic structural vibrations. Its most visually stunning feature is a massive 72-foot aerodynamic nose, meticulously shaped like a spear to pierce through air resistance. What makes this train truly revolutionary is its active shape-shifting capability. Specialized sensors covering the hull detect powerful wind currents or atmospheric pressure changes, automatically adjusting exterior components to maintain supreme stability without dropping velocity. Furthermore, its heavy-duty aerodynamic braking system can safely halt the train from maximum speed in just 2 minutes, establishing a brand new global benchmark for emergency safety. However, operating at these extreme parameters introduces immense geographical and seismic challenges, particularly in regions prone to intense tectonic activity. Japanese and Chinese engineers have spent billions developing automated seismic detection grids that cut power to the tracks the exact millisecond. An earthquake tremor is registered miles away. This intricate focus on safety highlights a fascinating contrast in global infrastructure philosophies. While the United States has historically focused resources on expanding its massive interstate highway system and domestic aviation networks to conquer its vast geographic layout, Asian nations have committed fully to high-speed rail to connect dense population centers. The rapid expansion of these networks represents a massive triumph for Chinese innovation, forcing us to recognize that the future of global transit is being rewritten on tracks rather than in the skies. As we look at these incredible machines, we are left to wonder how quickly this technology will spread across the world. Which of these spectacular high-speed trains impressed you the most today? Would you ever be brave enough to travel at 621 miles per hour inside a vacuum tube? Please share your fascinating thoughts in the comments section below. Give this video a like, and don't forget to subscribe to the channel for more deep analytical insights. China just built a car engine that is getting 106 miles per gallon, a staggering milestone that has left the global automotive industry in absolute shock. I am not exaggerating at all, as the official adjudicators from Guinness World Records have just traveled to the testing facilities, verified the data, and certified this mind-blowing achievement. The manufacturing powerhouse behind this technological marvel is Geely, the massive Chinese conglomerate that quietly owns premium global brands like Volvo, Polestar, Lynk & Co., and Lotus. Now, the top executives of this corporate giant are publicly stating that their new creation will comprehensively destroy every single hybrid vehicle that Toyota, Honda, and Nissan have ever put on the global market. Their chief executive officer recently walked onto the brightly lit stage at the prestigious Beijing Auto Show and essentially threw down the gauntlet, challenging the dominance of the entire Japanese automotive establishment. When you discover what this specific powertrain actually pulled off, achieving a historic thermal efficiency level that traditional giants have spent over 2 decades chasing but never managed to secure, you will instantly realize why every legacy executive in America should be losing sleep tonight. Subscribe to our channel right now so you can always be the very first person to discover groundbreaking technological shifts exactly like this one. This is not some far-fetched laboratory prototype, nor is it a conceptual design meant for auto shows, because this machine is already running on active production lines. The wildest part of this entire development is that it might quietly alter everything about what you choose to drive over the next decade. But to comprehend exactly how engineers pulled this off, we have to look closely at the rapidly evolving landscape of this industry. Welcome to Expand Knowledge. It is currently May 2026. And the global race for engineering dominance has reached a critical tipping point. For over 30 years, the entire automotive world looked to traditional engineering hubs for leadership in fuel efficiency, believing that foreign newcomers could never bridge the massive technological divide. Yet, the unexpected arrival of this record-breaking system proves that the rules of global manufacturing have completely changed while traditional brands were looking the other way. Today, this single innovation challenges decades of established engineering beliefs, forcing Western competitors to reevaluate their long-term survival strategies in a market they once completely dominated. This remarkable development is no longer just an experimental breakthrough, it is a commercial reality that is actively transforming consumer expectations across international borders. To truly comprehend how this engineering marvel became a reality, we must travel back to 1986 and meet a determined farmer's son from Zhejiang province. Born into poverty in 1963, Li Shufu did not begin his professional journey by assembling sophisticated automobiles. Instead, he started his very first business by manufacturing basic refrigerator components. With approximately $3,000 borrowed entirely from his supportive family, he established a tiny factory and chose the name Geely, which translates directly to lucky in Chinese prose. By 1994, he pivoted his operations to manufacturing motorcycles, and in 1997, he made a strategic move that caused experienced executives across Asia to openly laugh at his ambitions. He decided to build passenger cars without possessing any prior automotive industry experience or an established manufacturing plant. Journalists openly mocked him when he claimed that building an automobile was simple, famously stating it merely required 4 wheels and 2 comfortable couches, leading many observers to call him completely delusional. If you are enjoying this incredible journey, make sure to stay right here, because the most dramatic part of this story is about to unfold. Li Shufu simply refused to quit, and by 2001, Geely became the first private enterprise in China officially licensed to manufacture passenger vehicles. Then, in 2007, he attempted a move that Western analysts considered completely impossible. He boldly wrote an official letter to Ford Motor Company offering to purchase their premium Swedish brand, Volvo, but Detroit executives ignored his proposal entirely. He showed up in person at the prestigious Detroit Auto Show in 2008, yet Ford officials brushed him off once again, viewing his tiny firm with deep skepticism. Undeterred, he returned to their headquarters in 2009 with a detailed plan, and by 2010, the persistent farmer's son walked out of the building with Volvo in his pocket for $1.8 billion in cash. By 2018, he purchased nearly 10% of Daimler, making him the single largest individual shareholder of Mercedes-Benz, completely redefining global manufacturing alliances. Before we dive deeper into the mechanics of Geely's historic engine, we must address the critical reason why the global electric vehicle dream is quietly falling apart. On paper, driving a pure electric car sounds absolutely flawless, but the moment you try to live with one in the real world, significant structural cracks begin to show. Consider the daily reality of charging your vehicle. While commercial advertisements constantly promise lightning-fast charging, the actual truth is that you must sit at a station for 20 to 40 minutes just to reach 80% capacity. Try managing that tedious delay during a long family road trip with 2 restless children and a dog in the back seat. That is not a convenient refueling stop. It is a stressful hostage situation. Furthermore, extreme cold weather poses a massive threat to performance, as electric car batteries routinely lose 30 to 40% of their driving range when winter temperatures drop below freezing. That means if you paid $60,000 for a car with a 300-mile range, that distance suddenly shrinks to just 180 miles during a harsh Michigan winter. Even worse, when that complex battery pack eventually fails, replacing it will cost an unsuspecting owner anywhere from $10,000 to $20,000, which equals the price of a good used car just for a single part. We must also examine the severe environmental toll of extracting raw materials like lithium, cobalt, and nickel from massive, toxic open-pit mines. Cobalt mining in the Congo is plagued by documented human rights issues and child labor, which completely contradicts the green philosophy these vehicles are supposed to represent. On top of that, if every single American driver purchased an electric vehicle tomorrow, our aging domestic electrical grid simply could not handle the massive power load. The Department of Energy has been raising urgent warning flags about this systemic vulnerability for years, proving that forcing a total electric transition is not a sustainable solution. What do you think about these hidden drawbacks of electric vehicles, and have you ever experienced charging delays or range issues in cold weather yourself? Share your personal experiences and detailed thoughts in the comments section right below. While Western policymakers were caught up in intense debates over electric vehicle mandates, Chinese engineers were quietly perfecting an entirely different propulsion system, and the remarkable data they just released will completely redefine your expectations. In April of 2026, at the crowded Beijing Auto Show, Geely took the stage to unveil their innovative, intelligent hybrid system. At the absolute heart of this technology is a brand new, highly advanced engine designated as the BHE-15, which is a 1.5-liter 4-cylinder power plant. The very first metric displayed on the presentation screens stunned everyone in attendance, revealing an unprecedented 48.41% thermal efficiency rating. To put that technical milestone into perspective for everyday drivers, the standard gasoline engine currently sitting in your driveway only converts about 30 to 35% of its fuel into actual physical motion, while the remaining energy is completely wasted as heat escaping through the tailpipe. Even Toyota, the historical pioneer of hybrid technology that the global industry has respected for nearly 30 years, has seen its most efficient engine max out at 41% thermal efficiency. By achieving 48.41%, Geely has officially set a new world record, verified and certified by Guinness World Records, making it the highest thermal efficiency ever achieved in a mass-produced passenger vehicle. To give you a clear frame of reference, modern Formula One racing engines, which represent the absolute pinnacle of internal combustion engineering built by human hands, operate at roughly 50% thermal efficiency. This means Geely has brought an affordable family sedan within touching distance of multi-million-dollar racing technology, and they are doing it in a vehicle that costs consumers less than $10,000. When you pair this record-breaking internal combustion engine with their 308 horsepower electric motor and their advanced AI cloud power management system, the real-world efficiency becomes hard to believe. During rigorous testing conducted on a closed highway loop in sunny Hainan, the midsize sedan achieved an astonishing average of over 106 miles per gallon, Guinness adjudicators monitored the entire test to officially verify the fuel economy data, putting an end to any skepticism from foreign competitors. To understand just how dominant this performance is, we only have to look back at 2024, when Toyota drove their flagship Prius from Los Angeles all the way to New York to showcase their real-world efficiency, averaging 92.9 miles per gallon. Geely's new system outperformed that historic Japanese milestone by more than 12%, representing a massive technological leap forward. Representatives from Geely openly stated that this powertrain will comprehensively surpass any hybrid technology currently offered by Japanese legacy automakers. And looking at the verified data, that statement feels less like traditional marketing and more like a definitive shift in global industry power. What makes this transition even more alarming for Western manufacturers is that Geely is not the only domestic company achieving these numbers, as a massive wave of ultra-efficient vehicles is hitting the market simultaneously. BYD, the manufacturing giant that recently surpassed Tesla in total global electric vehicle sales, launched its fifth-generation hybrid system, featuring 46.06% thermal efficiency. This allows their vehicles to travel over 1,300 miles on a single tank of gasoline and a full battery charge, which is roughly the driving distance from Miami to Boston without making a single stop. This monumental shift is no longer confined to small sedans, as every major Chinese automaker has rolled out similar ultra-efficient powertrains over the last 18 months, including established brands like Changan, SAIC, GAC, Chery, and Great Wall. Even lesser-known brands like Aeolus have hit an incredible 45% thermal efficiency on their new family vehicles. Meanwhile, traditional engines manufactured in Detroit by Ford, General Motors, and Stellantis are mostly struggling to cross the 35% threshold, creating a massive technological generational gap. This highly disruptive technology will not stay contained within overseas borders either, because Geely strategically owns major Western brands like Volvo and Polestar, maintains a prominent luxury joint venture with Mercedes-Benz, and actively licenses its advanced powertrains to Western brands through its Dynamic Horsepowertrain Alliance. This means these ultra-efficient systems will rapidly filter into European and American passenger vehicles over the coming years. While Washington policymakers continue to argue over complex electric vehicle mandates and legacy executives in Detroit beg for protective tariffs, foreign engineers are quietly constructing the next 30 years of global driving infrastructure. Imagine pulling up to a local gas station just once a month to fill a standard tank that reliably delivers over 1,300 miles of driving range. This is no longer a distant concept found in science fiction movies. It is a commercial reality, actively reshaping global markets while our traditional domestic industries risk falling behind. The ultimate future of global transportation is no longer being decided in the historic design boardrooms of Detroit, because those critical decisions have already taken place across the Pacific, like in Hangzhou. Do you believe that a hybrid engine this incredibly efficient can completely destroy the ongoing electric vehicle revolution before it even gets a chance to start? Please share your fascinating perspectives, professional insights, and personal opinions regarding this critical technological shift in the comments section right down below. If you found value in this deep analytical breakdown, please remember to hit that thumbs up button. Share this video with someone who still thinks electric cars are the only viable answer, and subscribe to the channel so you never miss another exclusive look into how global technology is evolving.